Welcome to CollegeReadyMath's graphing a linear equation in slope-intercept form. This equation is in the slope-intercept form. When the equation is expressed in the slope-intercept form, it gives us a quick way to find the slope and y-intercept of a line. And it saves time in graphing, too. So when we've graphed equations, we found two ordered pairs that satisfy the equation, and then we graphed these points and drew a line. But watch this. When an equation is in slope-intercept form, we already have one point, the y-intercept. So in this equation, it's 0, 2. That's 1 point. And we need one more to graph the line. We can use the slope of the line to find another point. Remember that when the linear equation is expressed in a slope-intercept form, y equals mx plus b. The coefficient of x is the slope of the line. And here's how. Start at the y-intercept. The slope is 3/4, and that means that the vertical change in y is positive 3. So we count up 3 from the y-intercept. The change in x is positive 4. Count over 4 to the right, and there's the second point, 4, 5. Now we can draw the line. Taking advantage of slope-intercept form makes graphing easy. We just plot the y-intercept and use the slope to find the second point. Then we're ready to draw the line. Now try it yourself with this equation. Find the y-intercept, then use the slope to find the second point and graph the line. The y-intercept is 0, negative 1. Count the slope from here. The slope is negative 2/3. Now, there are two ways to work with this negative ratio. We can think of it as negative 2 over positive 3, or positive 2 over negative 3. If we think of it as negative 2 over positive 3, we count down 2, then 3 to the right. That gives us a second point at 3, negative 3. Now we can draw the line. So let's see what happens if we think of the slope as positive 2 over negative 3. We count up 2, then 3 to the left. That gives us a point at negative 3, positive 1. It's a different point, but it's on the same line. There's only one line that has a y-intercept of negative 1 and the slope of negative 2/3. What about this equation? Y equals 3. Where's the x? There isn't any. The coefficient of x must be 0. When the term with x is not written in the equation, it means that the coefficient of x must be 0. It does not need to be written because the product of 0 and any number is 0. That is the 0 property of multiplication. Also, the sum of 0 and any number is that number. That is the identity property of addition. It means that the slope of the line is 0. That makes sense. The graph of this equation is a horizontal line. We know that the slope of a horizontal line is 0. The y-intercept is the constant in the equation, 3. Does the line for this equation have a slope and a y-intercept? To find out, we'll have to write it in slope-intercept form. So that means we'll have to solve the equation for y. Notice that y is not written in this equation. Like before, this implies that the coefficient of y is 0. Then all values of y satisfy the equation. Therefore, the graph is a vertical line at x equals 2. Vertical lines have an undefined slope. Now let's take a look at what happens when we try to solve for y. We end up trying to divide by 0. Division by 0 is impossible. This is why this line has an undefined slope. The graphs of this type of equations are always vertical lines. Vertical lines have an undefined slope. If an equation is already in slope-intercept form, we don't have to do as much in order to graph the line. We already have a starting point, the y-intercept. From there, we use the slope as a map to find another point. That's it. You finished CollegeReadyMath's graphing a linear equation in slope-intercept form.